Day, oh, you to be on my side. I know I still get it. I got so many dreams. Spend my life thinking about so far. I don't wanna fail. Yes.
Okay, so time to get on the gym.
Always been so far from problems, cause you don't know the outcome. I don't count no bodies. My mama from the southeast. So don't bring no drama around me. Don't ruin the party. I wish you would, baby. Tell your brother we ain't good, baby.
Mr. Love,
While you let the new niggas
BBQ
switch your
Chicken is
mind
now
up.
following. Thank you,
Good,
Mr.
baby.
BBQ Chicken, for following. We are going
Everything I
to
thought you could, baby.
we are going
If you
to give
think
it
that
to
I'll
screen
ever miss a
because you get an
thing,
exam
answer no.
and
Answer
yeah,
no.
it's fun. Screen with me.
Answer. You believe what you wanna see. Ain't got nothing to do with me,
Well,
no.
so we're going to be creating a dedicated
Answer
sequel
no.
for.
Answer. Trouble in
So
a whirlwind. Don't replace your favorite. Say that you ain't solving. Your problem's been evolving. Must still care about me. My name's still all on your team. You was on my aim team, but now you won't let me be. I wish you would, baby. You couldn't come to Hollywood, baby. Cause you let these new niggas switch your mind up. Good, baby. Did everything I thought you could,
so right
baby.
now we're busy on
If you
the
think that
creating
I'll
a
ever miss a
dedicated
thing,
sequel
answer
for.
no. Answer no. Answer. You believe what you wanna see. Ain't got nothing to do with me, no. Answer
Let's put this
no.
a little bit higher.
Answer. Answer. Answer no. Answer no. Answer. You believe what you wanna see.
Put that up
Ain't got
there.
nothing to do with me,
Put that
no.
up there.
Answer
Nice.
no. Answer.
Okay. We're busy on creating a dedicated sequel for. Um, to create a relationship where position in the relationship must be dedicated to full. To create a relationship
Feeling so tired, I really feeling so. Feeling so tired, I really feeling so. I've been so tired of everything you do, everything you do. I've been so tired of everything you do. From the south in a silver gray, always seem to go back, go back. From the south in a silver shade, always seem to go back, go back. I've been so tired of everything you do, everything you do. I've been so tired of everything you do. Been so tired, I've been feeling so. Been so tired, I've been feeling so.
These are the considerations we can use to the business. Maybe very unique, unique name between the so the performance level, the turnover, the power, and then to something equal and to I expecting the people and people and games. Too many G's. Like you are saying something, too many G's. Right. Like declaration, you have to go and check also with the declaration. And people, so so basically, isolation will determines the short order and look of its fields. Um, cool, perfect. Um, so there living structures. So to create the fields. Um, so now we're going to look at some considerations. So what we're trying to understand, what we're trying to do is to each table use a certain pattern that I usually consider to be best practice. So when it comes to something like creating the table, dimension and the step table, we are considering things that much the treatment to so if you create table here, then you can see the tool you have to use each table, you something with your friend people table. So let's say we use the let's say the text, the inch, the options for using speaking. And they become super deep and you can do factual those are the facts. They were let's quickly go to this previous section. We will show we're facing the factual though. When you're facing the factual though, it's one way to fact tables, those quantitative tables, trying to tell, trying to create those, trying to something data. And basically, let's break down the rules of the data. So in the practical structure, we use the data variables, it will be the ID column, date columns of uniquely for every line of data is something table. And with the linking tables, the linking tables basically think of them as a way of sort of a statement of plans to the it tends to information and process in the process. So for example, we have an ID column with just another factor. In our dimension table, we will also have an ID column by making ID column with a unique value to what that ID column would represent in a section. Usually, well, I think section is a picture. So it will be a section with the ID maybe one for maybe for example, product name, right? So every product I use is one product. So what should it gives context to our ID card. For example, people, places, dates, staging tables are not sure. Staging tables are basically the step before you input the data. So for example, you have a table factory, everything factory transport data from one variable to another. So when you first transport the data into the second database, what it will do is it transports that data in its raw format in input format into that staging table. From the staging table back into the final table where it's the memory is where all of the from the staging table to the final table where it will be landed is where the transformations will happen. So for example, you have 20 columns coming from source, you go all 20 columns goes into the staging table. Now, only the table that you want to display in your final output or your final output table, that table will maybe say take 5 columns. So only take five columns and then move it into the um, final output table. So that would be because on a staging table, a staging table is basically an intermediary table set that happens before transformation. So, for example, when a data warehouse is composed of factory dimension tables, and staging tables are often used as part of the data warehouse loading process to ingest data from sources. So when designing a star schema for small medium-sized data set, you can use your preferred database such as SQL. For large data sets, to make benefit from implementing the data warehouse in Azure Science Analytics instead of SQL. Um, it's important to understand that there is some key differences in crazy tables. Cool. Let's talk about centrifugal trips. for the what do we mean by data integrity concern? So in a dedicated SQL tool inside analytics, the going support policy in concern it's found in other so this means that the jobs used to load data on a thing is one algorithm. So this is a very important thing to understand. When, especially when you come from a background of on-prem SQL, where you have these constraints which ensure the integrity of the sample. So, for example, um, the foreign key, right, or foreign key unique constraint. So, for example, if you have a primary key and the primary key needs to have a specific foreign key assigned to it, and say, for example, you have two foreign keys that are assigned to it, the integrity isn't kept, where so the check for integrity isn't kept. So you need to ensure that it's manually kept, else that foreign key will disappear twice. Um, indexing, indexing is very. A lot of people have differing opinions on indexing or how to use it. Um, when creating dedicated SQL pools, cluster indexes, and the functions will serve the default index type is cluster cornerstone. So the default index type is cluster column row. Perfect. Yeah, I'm not usually talking so fucking much, but anyway. Yeah. So this index type offers significant performance advantages when querying large quantities of data in a typical data warehouse schema and should be used where possible. However, there's some tables which may include data types that can't be included in a classic console. For example, var binary maths, which a classic index can be used. So let's take note of that. A var binary maths var binary maths data type is not supported where classical. Uh, let's talk about the solution. legal distribution.
Your choices shape the ones you claim to love. You're so desperate, they try to love you. And I want to help you get to help you be the person that you were meant to be. Just have to walk right through uncertainty. I want the best for you.
So regarding distribution, Azure Synapse Analytics SQL pools use a massive parallel processing architecture. So let's write it down. It uses a massive wow, well, processing architecture. Yeah, these parallel processing architecture as opposed to the symmetric multiplication, which is used this one is in the execution from the data table distributed of resources across a pool of nodes. The technical level is because of some point in the past. Alright, surrounded.
I wanna wash my face off in a creek. Tell myself
Robin,
that it feels better than my sink. I
carefully
wanna
taken.
stare at an Andy Warhol
You see
piece.
that the
Make
actually
it
they
look
use in
like I
distribution.
know
One
it
is, I
could
mean, we are
hurt
in
me.
the
I try to
different type of
read in between all
distributions.
the lines, even though
Okay,
I
cool.
know
What is a
you know
hash?
just why.
So a
Every time you
deterministic
look at me,
hash value
I
is
don't have to
calculated for the
make
specific
believe
column
all
and
the
used to assign the rows
oceans
completely.
keeping them alive.
So let's just say
That song
um,
brings back memories.
it
Paintings try to speak
is
to me, but you don't have
calculated
to do a thing to part the sky. And
for
I don't
the
care if nothing's
specific
behind.
column and used to
I
assign
wrote a poem that no
the
one
row
else has
to
heard, and
a
I worked to make
compute
sure that
node.
it's not just words. I played the records you
Column
gave me.
assign the row.
First could have been something there, but it's
What is the right
empty at
Robin
worst. I
distribution?
try to
Where the rows are
make this
distributed
something
evenly.
defined, even though I know that I'll go blind. But every time you look at me, I don't have to
And
make
what is
believe
replicated
all
where a
the
copy of the table is stored in each
oceans
complete node.
keeping them alive. That song brings back memories. Paintings try to speak to me, but you don't have to do a thing to part the sky. And I don't care if nothing's behind.
So, what are the recommendations? What are the recommendations for each in a practical sense? What would the recommendation be for in terms of distribution and the types of distribution we are assigning to tables? In the previous section, we've seen that there are different types of tables. For example,
And I'm
fact
alive.
tables, dimension tables, staging
That
tables,
song
right?
brings back
So,
memories.
in
Paintings
terms of
try to
best
speak to
practices,
me, but you don't
we
have
can
to
go through
do
this. We will
a
say
thing to
recommendations
part
for
the
using for
sky.
the
And I don't care if
dimension
nothing's behind.
tables, fact tables, and staging tables. So it is best to use the replicated distribution for smaller tables, right? So our smaller tables are usually made up of dimension tables. So it's a replicated uh, for dimension tables. It's for smaller tables, and this is to avoid data shuffling when joining to distributed type tables. If tables are too large to store, each compute node use a hash distribution. So use a hash distribution for larger tables. And for a single table, we use our round robin. Yeah. Okay, hash distribution, we're gonna go here. Perfect. Um, cool. Um, let's go a little bit deeper into creating dimension tables.
All in my bag, all in my bag, all in my bag, you know. All in my bag, all in my bag, all that I have, you know. Gave you the gate key and the
So when you create a dimension table, we need to ensure that table definition includes
nigga, you need time, we time, and it still wasn't enough. I believed all of your lies, and it still wasn't enough. Say it, don't let it talk to you crazy, but then
it must include the circuit
what do we try
key
hide? It's feeling just a little bit shady. Can't get back the time that we wasted.
and ultimately
Patience, don't get me mistaken. I'm breaking. At least I give it all to you, baby. Oh, I'm
as well as
wondering how you sleep at night. And honey, I
columns
agree. Don't want me
story
'cause you took off with mine. Now I'm here
attributes
waiting, 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 waiting for you.
of the
Yeah, me, I'm
dimension
going crazy.
that you want to use to do everyday things. Perfect.
Gave the gate key the bag, and it still wasn't enough. Let you walk while you back, and it still wasn't enough. I give you me time, free time, and it still wasn't enough. I believe you and your lies, and it still wasn't enough.
It's often easiest to use an identity column to auto-generate an increments inside of the key. Other way of generating keys is also the following shows the create table sequence for hypothetical term customer dimension table. Create table, term customer key, what's distribution.
Give you the words to find a way to be mad at me. Thought you were tripping, but you're living in a fantasy. No, wondering how you sleep at night. And honey, I need your heart because you took off with mine. Now I'll be waiting, 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 waiting for you. And you got me going crazy, 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 crazy for you. Oh, all in my bag, all in my bag, all in my bag for you. All in my bag, all in my bag, all in my bag for you. All in my bag, all in my bag, all in my bag for you. All in my bag, all in my bag, all that I have
Yeah,
for you.
actually, complex. If you intend to use Snowflake schema in which dimension tables are related to one another, you should include the key for the parent dimension, the definition of the child dimension. For example, the following SQL code should be used to move geographical address details from dumb customer table to a separate dumb geography. Alright.
If you say so, I'm all alone again. Knew you would say no, you wouldn't understand. Please don't let me go. I'll be alone again. I'm
You know,
on
what
my own again.
time
I've lost all my
dimension
friends.
table?
Hey, old friend, I hope that we make it. But before the end, I know that I can't take it. Maybe I'll get lucky and I'll finally make it. How would I descend? I know I need to face it.
Most data warehouse include a time dimension table that enables you to aggregate data by multiple hierarchical levels or time interval. For example, the following example creates a dumb date table for the attribution of subject dates. Date, date, key.
Bring out the dark side of my head. Oh, oh,
Dimension
bring out the
tables, creating fact
dark
tables.
side of my head. If you say so, I'm all alone again. You would say no, you wouldn't understand. Please don't let me go. I'll be alone again. I'm on my own again. I've lost all my friends.
Include keys for each dimension. Criteria was included for each dimension you shared latest and attributes on the mid-range. Attributes like attributes and numeric uh, numericals. Okay, cool. Hey, what's up? What's up? What's up? What's up? What's up? Master, I love barbecue chicken. Who are you, sir? Master, I love barbecue chicken. Who are you? My man was good. I'm just posting a link quickly, and then I will be back to the study in a minute. Okay, we are jumping back into the contents. Master, I love barbecue chicken. Who the fudge is that? Okay. Good to have you on stream. Good to have you on stream. Um, okay, so we create some staging tables. Staging tables I use temporary storage. Um, it's temporary storage. For data as it's been loaded. It's been loaded. So let's put here, add some context into a data where, um, whoa, into a data warehouse. Okay, we got that now. So now, a typical pattern is to structure the table to make it as efficient as possible to ingest data from its external source, often files in data lake, into a relational database, and then use SQL statements to load data from staging table into the dimension table. The following code example create a staging table for products that automatically load into dimension. This is wrong problem. Okay, and now we're gonna go into external things. External tables. So we won't be creating them because if the external tables they probably have already been created. So in some cases, if the data to be loaded in files with appropriate structure, it can be more efficient to create an external table that references the file location. This way, the data can be read directly from the source file instead of being loaded into the relations of the following example shows how to create an external table. Uh, the references files in the data lake associated with the energy sign up to workspace. external data source link to data location, creation of data source stage file, what location is in location data lake. Okay. We're gonna load. Now we're gonna look into loading a new data warehouse table. Yeah, yeah. So at a basic level, loading a data warehouse is typically achieved by adding new data from files in a data lake into a table into a data warehouse. The copy statement is effectively to accomplish tasks in the following way. Uh, let me see. You copy statements. Software. Now we're gonna say this considerations. This considerations when loading data warehouse tables. One of the most common speaking out of my India. One of the most common patterns for loading a data warehouse is to transfer data from source system file into a data lake. Just one of the most common patterns for loading a data warehouse is to transfer data from source systems to files in a data lake. Ingest
Five crimes, they didn't pay that birds like kerosene. That birds like kerosene. What I brought onto you, I swear I'll carry to my grave.
uh,
I swear I'll carry to. You know that look
Anil, is that you, Mister
I've been wearing that for
Mister?
days.
I love barbecue chicken.
I want your eyes sit on my
That's good to have
eyes.
you. Good to have
Now
you.
that I got you here, there's questions to be asked.
One of the most common patterns for loading a data warehouse is to transfer data from source systems to files in a data warehouse, in a data lake. Ingest the file data in staging tables and then use SQL tables to load the data from a staging table into dimension fact tables. Usually, data loading is performed as a periodic batch process with inserts and updates to the warehouse that coordinated occur at regular interval, for example, daily, weekly, or monthly. In most cases, you should implement data warehouse load process to perform tasks in the following order. So first, we're going to ingest the new data. to be loaded into the data lake, and then after that we are gonna load data from files into fusion tables in the relational warehouse. We're gonna load data file. We're gonna load data from files into fusion tables in the relational warehouse, and we're gonna load
The sun needs the moon,
the dimension tables from dimension data.
swallowed the weather. Busy old fool. Now the days last forever. The center won't hold. Center the ruins. To burn through the night.
Variable.
Sound the retreat. It fractures the whole. A brutal
We're
escape.
gonna update
Frantic like a
existing
child.
rows,
Crawling to its head.
or we're gonna insert rows. And and depending on how your table is structured, it will generate something. So just
Storm. Cause the sun needs the
use
moon.
boom 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 boom
Swallow
boom
the
boom boom.
weather. Summer of love.
Then we're gonna load the fact tables from the fact table, the data
Pull
and
to
thing
the
table.
bottom. Tumble and fall. Striking up to heaven.
And sending the design reviews, and then we're gonna perform posting optimization. Um, um, optimization by updating
The sun needs the moon.
indexes and
Swallow the
table
weather.
distribution.
A beautiful
Okay.
gesture.
After we use the
A
copy
beautiful
statement to load data,
future.
um, no, no. After we use the copy statement to load data in staging tables, we can use the combination insert update merge statement to load staging to dimension. Alright. Now we're going to let's know that was that for loading data warehouse tables. Now we're going to talk about querying data warehouse tables. So let's create a new flow here.
Swallow the feather.
Querying
The
data
sun needs the moon.
warehouse. Boom, 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 boom,
Swallow the
boom, 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 boom,
weather.
boom. So query data warehouse very similar to normal on-prem SQL, but there is a few there's slight differences which you should keep in mind. So when the dimension table, effect tables, and data warehouse have been loaded with data, then you can use SQL to create tables and analyze the you contain. The T-SQL syntax is used to create tables. I'm going to put it here TSQL tables. So aggregating measures by dimension attributes. What do we mean by this? So most data analytics with data warehouse involves aggregating numeric measures. In fact tables by attributes and dimension data. So most data analytics for the data warehouse will aggregate numeric measures and effect tables and attributes from dimension tables. Because of the way a star snowflake schema is implemented, queries to perform this kind of aggregation rely on join clauses to connect structured tables to another and group by. So the support uses uh, join clauses and uses group by clauses. Right, you group by clauses and other group by clauses. Sorry, I'll get back into it now. All right, all right, all right, cool. Now we are gonna go through. Where is this now? Come on. Yeah, for sorry guys, got a little bit distracted there. Okay, cool. So for example, queries, for example, in the example that we use, where we show fact sales in the data table, the hypothetical table, we also indicate sales amount by years and quarter. So you will select the column that you're looking for, If you want to aggregate it, you use something like a sum of a specific column. You'll say from whichever table, you join it to whichever dimension table that you're looking to join it to, on whichever column it needs to join up to, group it by the same column that you aggregated it by, group it by the same columns that you did not aggregate it by, and then order it in whichever way you're looking for. So, basic syntax. So you can also join as many dimension tables as needed to calculate the aggregation unit. So for example, the following code extends the previous example to bring down the quarterly sales totals by simply pasting the customer address or details in the dump customer table. So yeah. So yeah, there's some interesting things that can happen. So for example, let me look at other considerations. How would we do the joins in a snowflake schema? So when we use a snowflake schema, dimensions may be partially normalized. So they might be dependent on one another or related to one another. So it requires multiple joins to relate fact tables to snowflake dimensions. So for example, suppose your data warehouse includes a dump product, dimension tables from which the product categories have been normalized into a separate dump category table. So every product in the product table can be categorized in this dump category table. So a query to aggregate might look something similar to how to explain. You have your select statement, you say from whichever table sales, you join it to the dump product category on product category for where for example the product key is equal to the product key from the product key from the dimension table is equal to the product key to the fact table, and then we join it again, we join now our dump category table, and our dump category table would be joined from our product table. So columns that will be joined will be our the column that's in our product table, and we say from the product table we join to the category table, and we order it in group by it, and that's how we would join it into basically a snowflake type of stream. Cool. Let's talk about ranking. Ranking is an interesting topic because it's a very useful thing if you're trying to assign numerical values in data that does not have that numerical value assigned, and you want it to be the numerical values to be ordered by instruction in such a way that you want the data to be structured. So let's start off with using ranking functions. Perfect. Using ranking functions, what we are gonna do. So I mean, another common kind of analytical query is to partition the results based on dimension attributes and rank the results. So you partition the results on dimension attributes, and then you want to rank each specific result of that partition. So for example, you might want to rank stores each year by their sales revenue. To accomplish this goal, you can use T-SQL for ranking functions such as row number, rank, dense rank, and enter. So let's say let's clarify the row and number, yeah, rank, well, all the caps, rank, whoops, row number, rank, dense underscore rank, and style. Perfect. This function is able to partition data over categories, each identifies a specific value, which indicates the relative position of each row within the partition. Let's go into row number. Let's see what it is. So a row number returns the ordinal position of the row within each partition. So let's just write down, so returns the ordinal position of the row within the So what does this mean? An example would be the first row is number one, the second is number two, and so on. So it just basically whichever row is already there, it would then assign a rank to it based from one to two. Simple. Simple row number is going to assign a rank. What does the rank function do? The rank function returns a rank position, and it returns a rank position based on how the results were ordered. Oops. Let me open a message. Not for me. Not for me, not for me, not for you, not for me, not for you, not for anyone. Cool, 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 cool. So for example, what is a rank? In a partition of stores ordered by sales volume, the store with the highest sales volume will be ranked one. So if multiple stores have the same sales volume, they'll be ranked the same. The assigned rank and the rank assigned to subsequent store reflects the number of stores that have higher sales volume between times. What is dense rank? Dense rank returns rows in a partition in the same way as rank, but when multiple rows have the same rank, the subsequent rows are ranking position with no tiles. So works the same whoops, as rank, but when multiple rows have the same numeric value that you ordered by um, ordered by the the subsequent rows are ignored. Let's let's take a step back, right? Let's go back into rank. We said that the rank returns the rank position in each row of the ordered results. So, for example, in a partition of stores ordered by the sales volume, the store with the highest sales volume is ranked one. If multiple stores have the same volumes, they'll be ranked the same. The assigned rank subsequent store reflects the store number of stores that have the highest sales. If multiple stores have the same sales volumes, they'll be ranked the same. And the rank assigned to subsequent stores reflect the number of stores. I don't understand that. If multiple stores have the same sales volumes, they'll be ranked the same. So they'll be, for example, 1, 2, 2, and because the second and third row will have the same sales value. So it won't be 1, 2, 3, it'll be 1, 2, 2. If multiple stores have the same sales volume, they'll be the same, and the rank assigned to a subsequent store reflects the number of stores that have higher sales volume in types. Okay, cool. Then it's a rank repetition to remember multiple the same rank subsequent rows ranking position no sense. What is entire? Sounds very dangerous to talk to something called entire. So either what is the entire return specific percentile in which the row falls. I'll give an example of this. in a partition of stores ordered by sales volume, enter returns the quota, which is store's volume principal. Right. How do we retrieve an approximate count? So let's talk about it. How do we retrieve an approximate count? So while the purpose of a data warehouse is primarily to support analytical data models and reports for the enterprise, data analysts and data scientists, they often need to perform some initial data exploration just to determine the basic scale and distribution of data. So for example, the following uses the count function. So count function for all in caps, count function. The volume of data warehouse can mean that even simple query is counting on the might need to take into. In many cases, precise counting is required. If the data set is really large, you can use the APPROX USD underscore distinct function. What the hell is keep on count? We're gonna use this for smaller data, smaller data sets. So the approximate count distinct, it uses a I think called an algorithm called hyperlog. Uses bunch of uses hyperlog log algorithm, and the result is guaranteed to have a maximum error rate of 2%. Worth 97% probability. The counts are less accurate. The counts are less accurate in using the approximate count system for an approximate, for example, an approximate comparison of Gary cells with a large volume of data. The query using approximate function completes more quickly, and the reduced accuracy may be an acceptable trade-off. Which of the following table types should an insurance company start using of the customer attributes which claims will be attributed? Which of the following table should insurance companies store details of the customer attribute? That shows you the customer attributes. That'll be a smaller data set. That would be we just probably have like customer ID, customer name, and that seems to me like it would be in a dimension table because dimension tables contain values um, that are not entirely ID dependent, and they are very uh, text rich, and because it can't be a very big table. So okay, I'm gonna go with dimension table. So you can create dimension table for products data, assign a unique numeric key for each row in a column named product key. The product key is only defined in data warehouse. What kind of key is product key? Let me see. Let me read this. You can create a dimension table for product data. You create a dimension table for product data, assigning a unique numeric key
I'm too
for
old for
each row in a
this.
column.
Been around this
Create a
broken
dimension
down
table
for way
for
too long.
product data. Oh, let me read it
Left
here.
my home for
I
this.
create the dimension
Starry
table
eyed, it's
for
no
product data,
surprise. Things went wrong. What
assign a
was I
unique
thinking,
numeric key for
babe?
each
All
row
the
in a
mistakes
column
I
named
made.
product key.
I should have never left your
The product key
side.
is only defined
When
in
you
data
were there
warehouse.
for
Which kind of
me,
key is that?
you set my
It would
worries
be
free.
a
Now
surrogate.
I got to change my mind. Oh, 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 I'm coming
What
home.
distribution option would be the best for a sales fact table that contains billions of
I'm coming
records?
home.
Fact tables. For fact tables, what distribution option would be the best for a single fact table that contains billions of records? Hash. Hash can handle large data sets. Hash was recommended for best practices in use for fact tables. You need to write a query to return the total of the units produced. You need to write a query to return the total of units produced and then enter in the production rate. I need to write a query to return the total of the units produced. You
I'm
need to
too
write a
old for
query
this. Been around this
to
broken
return the
down
total of the
for way
units
too long.
produced.
Left
Okay,
my home
the
for
fact
this.
production table
Starry eyed, it's no
aggregated by the
surprise. Things
product
went wrong.
name unit in the
What
fact
was I
product total
thinking,
number of
babe?
records
All the mistakes I made.
used to select.
I should have never left your side. When you were there for me, you set my worries free. Now I got to change my mind. Oh, 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 I'm coming home.
You use a rank.
I'm coming home.
You use a rank function in a query to rank customers in order of the number of purchases they have made. Five customers have made the same number of purchases and rank information. Right. You use the rank function in the query to rank customers in order of the number of purchases they made. Five customers have made the same number of purchases and all ranked equally. What rank will the customer or the next rank number of purchases be assigned? So the rank function will be you need to compare approximate production volumes by product while optimizing query response time which function to use.
Take you down,
You need to compare
take you
approximates here.
slowly away.
Let's check
Close
my
your
answers.
eyes, let me show you the way to my
Oh,
heart.
got all of them right. Brilliant.
Feeling empty today, my heart is feeling empty empty today. You're taking my breath away. 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 You're backing out. I see your silhouette. You taste
Well, I need to take a quick break. I will be back now.
jealousy and regret. Always disguise how you hurt me within. Somehow I like when you get under my skin. Let me take you down, take you slowly away. Close your eyes, let me show you the way to my heart. Feeling empty today, my heart is feeling empty today. You're taking my breath away. 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 I'm not perfect. I'm still searching. Somewhere in between clubs and churches. Somewhere in between parades and hearses. While I have you here in person, let me take you down, take you slowly away. Close your eyes, let me show you the way to my heart. Feeling empty today, my heart is feeling empty today. You're taking my breath away. 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 You're taking my breath away.
Daydreaming of you. I'm leaving on a full moon. Stay with you watching cartoons. Maybe we'll stay singing our tune. I don't wanna leave, but I gotta go. Oh no, I don't wanna leave, but I gotta go. Oh no, no. Stay dreaming, full view. Ain't been sleeping up too few minutes in a day. Ain't got time to play, but I'll probably miss you. Ooh, I don't wanna leave, but I gotta go.